Alright, let's talk about gold. It's the stuff of legends, the reason for rushes, and a symbol of wealth that has driven people to do some pretty crazy things. In 2024, the world managed to pull about 3,638 tons of it out of the ground. That sounds like a lot, doesn't it? But when you look at the big picture, it's just a drop in the bucket. Throughout all of human history, we've only managed to mine a grand total of about 212,000 tons. If you gathered all that gold together, it would form a cube with sides just 72 feet long. That's it, all the gold ever mined could practically fit inside a small apartment building. The real kicker is that the gold we can actually get to is a tiny fraction of what's on our planet. Scientists figure there are about 48 billion tons of gold on Earth. So why are we working so hard for so little? Well, about 47 billion of those tons are trapped deep inside the Earth's core and mantle, completely out of our reach. It's so far down that we have absolutely no way to access it. The gold we're fighting over is in the planet's crust, making up less than 1% of the total. It's a cosmic joke, really. The metal arrived here billions of years ago from supernova explosions, delivered by meteor showers, only to get buried where we can never touch it. This scarcity is precisely why gold mining is such a tough, demanding business. You aren't just digging up shiny nuggets left and right. On average, a ton of rock from a modern gold mine, that's 2,000 pounds of solid earth, will only yield about 0.03 ounces of gold. Let that sink in. You have to move a literal mountain of rock just to get enough gold to make a simple wedding band. It's an incredible amount of work for a very small reward. This is why a newly discovered gold deposit can take anywhere from 10 to 20 years before it even starts producing gold commercially. It's a long, expensive, and dirty process before you see a single flake. The countries leading this charge have changed over the years. It wasn't too long ago that South Africa was the king of gold production, digging deeper than anyone else. Today, the top players are a different group entirely. China now leads the world in gold output, followed closely by Russia, Australia, Canada, and the United States. These nations are now at the forefront of the global hunt, constantly developing new technologies and methods to extract every last possible speck of this precious yellow metal from the ground. It's a relentless pursuit, driven by the simple fact that there's only so much of it to go around, and everyone wants a piece. So, how do we get this stuff out of the ground? It's not as simple as swinging a pickaxe. There are three main ways it's done, and none of them are easy. The first is open pit mining. This is what you probably picture when you think of a massive mining operation. Miners use heavy explosives to blast away the surface of the earth, layer by layer, exposing the ore underneath. Then giant trucks and excavators haul away the rock for processing. This method is cheaper for gold deposits near the surface, but the problem is, we're running out of those easy-to-reach places. The surface has been picked over, forcing miners to go deeper. When the gold is buried far below, they turn to underground mining. This is a whole different level of difficult, dangerous work. Miners have to create a network of tunnels and shafts that can stretch for miles into the earth to reach the ore veins. The Mponeng mine in South Africa is the deepest in the world, going down over 2.4 miles. Down there, the rock temperature can hit a blistering 140 degrees Fahrenheit. It's hot, cramped, and incredibly risky. These days they're starting to use drones to fly into the most dangerous, unstable areas to map them out, but it's still a job that requires a special kind of courage to clock in every day. Then you have the oldest method of all, placer mining. This one is all about physics. Gold is incredibly dense, about 19 times denser than water. Over millions of years, erosion washes gold particles from their source rocks into rivers and streams. Because it's so heavy, the gold settles at the bottom of riverbeds. Placer miners use this to their advantage. They scoop up gravel and sand from the river and use pans or sluice boxes to separate the heavier gold from the lighter material. It's the classic image of the old-time prospector, and while it seems simple, it's back-breaking work that often involves standing in cold water for hours on end. No matter the method, the goal is the same: move an enormous amount of earth to find a tiny amount of gold. Whether it's blasting a crater into the landscape, tunneling into the planet's depths, or sifting through a riverbed, each technique comes with its own set of challenges and dangers. It's a testament to how badly we want this metal, that we're willing to go to such extreme lengths to get it. This is the definition of a dirty job, a gritty, physically demanding process that separates the dream of finding gold from the harsh reality of extracting it. Once the rock, or ore, is hauled out of the mine, the real work of separation begins. You don't just find a solid gold nugget, you find rock with microscopic gold particles embedded in it. The first step is to break it down. The ore is sent to massive crushers that pulverize the huge chunks of rock into smaller, more manageable pieces. From there it goes into ball mills, which are giant rotating drums filled with steel balls. These mills grind the rock into a fine powder, almost like dust. This process is essential because it frees the tiny gold particles from the surrounding rock, making them accessible for the next stage. With the ore ground into a powder, it's time to separate the gold. In the past, miners often used toxic substances like mercury or cyanide to leach the gold out, but these methods caused horrific environmental damage and are now banned or heavily regulated in many countries. Today, refineries often start with mechanical methods that rely on gold's density. They might use gravity tables, centrifugal force, or liquids to get the heavy gold to separate from the lighter waste material, which is called tailings. It's a cleaner way to get a concentrated form of gold before the final purification. To get the gold truly pure, it has to face the fire. One common method is called fire assay, where the concentrated ore is mixed with a substance called flux and heated to extreme temperatures, over 1947 degrees Fahrenheit. At this heat the gold melts, and the flux helps separate the remaining impurities, which form a layer of waste called slag on top. The slag is scraped off, leaving behind a more purified form of gold. This process is often just the beginning of purification, as it gets the gold to a certain level of purity, but not the near-perfect state required for investment bars. For the highest level of purity, refineries use more advanced techniques. The Miller process, which is faster and cheaper, involves bubbling chlorine gas through the molten gold to remove impurities, achieving about 99.5% purity. For the absolute purest gold, they use the Volwyl process, which involves electrolysis. An impure gold bar is submerged in an acid solution, and an electric current is passed through it. This dissolves the gold and redeposits it on a pure gold cathode, leaving behind any final impurities. This method can achieve an incredible 99.99% purity, creating the gold you see in high-grade investment bars. After all that digging, crushing, and burning, what do we do with this incredibly pure gold? A huge chunk of it, about 49% of all the gold mined, ends up as jewelry. Its unique properties make it perfect for this. Gold is extremely malleable and ductile, meaning it can be hammered into thin sheets or stretched into a wire without breaking. In fact, all the gold ever mined could be stretched into a tiny 5-micron thick wire that could wrap around the Earth 11.2 million times. It also doesn't rust or tarnish, which is why that ring on your finger stays shiny. The rest is divided among investors, central banks, and industrial uses in electronics and dentistry. Once refined, the gold is typically cast into bars, often called ingots. These bars are stamped with a serial number, the refiner's mark, and their purity level. This isn't just for show, it's a critical step for authentication and tracking. These certified bars are then transported to secure vaults around the world or sent to manufacturers who will melt them down to create jewelry, coins, or electronic components. From a massive dirty mine to a highly secure vault or a delicate necklace, the journey is long and complex. It transforms from a hidden speck in a rock to a globally recognized symbol of value. But we can't talk about gold without talking about its true cost. And I don't mean the price tag. The environmental impact of mining is staggering. Open-pit mining, with its reliance on explosives and heavy machinery, can leave behind massive barren landscapes that are essentially dead zones, unsuitable for farming or any other use. The waste rock, or tailings, can contain toxic substances that leach into soil and water supplies, poisoning ecosystems for decades. The pursuit of this shiny metal often leaves a permanent scar on the planet that can't be polished away. Then there's the human cost, which is arguably even more devastating. The gold industry is plagued with serious labor issues, including forced labor and extreme poverty. In some regions, entire families, including young children, are forced to work in dangerous artisanal mines for scandalously low wages, trapped in a cycle of debt. A United Nations report found that as many as 40% of gold miners in some parts of Brazil are victims of human trafficking. Workers face constant risks, from tunnel collapses in underground mines to chronic health problems for placer miners who spend their lives immersed in contaminated water. It's a dirty, dangerous business, and the glitter of gold often hides a very dark story.